Ever wish you could use your Android phone or tablet to control your Arduino? Despite what you think, it isn't that hard or expensive. In fact, it's quite easy and very affordable. Serial Bluetooth modules come in a variety of shapes, sizes, and prices, but in this demonstration I'll be using an inexpensive module. It's less than $7 online from a variety of sources. In this video I'll demonstrate how to connect, control, and use a Bluetooth serial module to transmit and receive data over Bluetooth using the Arduino and a simple Android application you can write yourself using MIT's browser-based drag-and-drop programming language, AppInventor. Note that there really isn't a project centered around this video. It's intended to serve as a demonstration of how to go about connecting the two devices and provide an introductory framework that you can use to gain enough understanding to develop your own Bluetooth-enabled projects and applications. Since there are two devices involved, there are two separate programs, one for the Arduino and one for the Android device. Neither program on its own does anything. The two programs are symbiotic in that they work together to demonstrate how Bluetooth can be used to share data. I see it as a sort of proof of concept. It's up to you to take what I've shown here and create something wonderful. Now, the hardware used for this video include the Arduino itself, a serial Bluetooth module, an Android device like a tablet or a phone to transmit the data downstream to the Arduino, and a Bosch BMP180 atmospheric pressure sensor to demonstrate transmitting data upstream from the Arduino to the Android device. I could have used a momentary switch, a variable resistor, a light sensor, or any number of other sensors to provide data to transmit upstream, but to be honest, I have a strange fascination with the pressure sensor and have used it in several of my videos. Perhaps part of it's because the BMP180 is easy to connect to the Arduino and doesn't require a lot of connections. The Bluetooth module is a serial device, and I used the software serial library to connect it via pins 5 and 6. I could have used the hardware serial pins 0 and 1, but since the Arduino's program upload process uses the same pins, I figured it would avoid complications of potential garbled data if I used software serial instead. No library of any kind is needed to use the Bluetooth module. All that's needed is to open a serial port at the appropriate baud rate, more on that later by the way, and monitor that serial port for received data. Transmitted data is serially printed to the same open port. As far as an appropriate Android device, any device running 1.5 Cupcake or later equipped with Bluetooth will work just fine, although according to the AppInventor website, Android 3.2, which is Honeycomb, or earlier does require a few extra configuration steps to get the AppInventor AI companion application set up properly. As I mentioned earlier, this demonstration also uses a BMP180 pressure sensor connected via I2C, but with a little modification of the code, any one of a variety of sensory input devices could be used. Here are the connections used to connect it all up for the purpose of this demonstration. You can see the display connected via SPI to pins 8 through 13, the BMP180 connected via I2C, and the Bluetooth module connected serially to pins 6 and 7. I do apologize. In the introduction, I believe that I said it was pins 5 and 6. It is actually 6 and 7. As you can see, it's a simple layout. There's nothing complex here. 3 devices connected to various pins on the Arduino. Now on to the code. We'll demonstrate bidirectional serial communication over Bluetooth using an attached Bluetooth module and an Android application running a tilt sensor demo application written using AppInventor. Now the program establishes a connection with the Bluetooth module, and once it's connected to the Android device, moves a box on the screen in response to tilt sensor data being sent over Bluetooth from the Android device. There's also a slider on the Android app that allows the box to be resized. Now, upstream data transmission is demonstrated by reading sensor data from the BMP180 module and sending it upstream in response to a button press on the Android application. You can download the Android app here. I'll provide this link in the description of the video as well. If you do have concerns about installing the app from an unknown source, you can visit the MIT AppInventor website at this link here, which I'll also provide in the description below. Once you're on the website, you can download the source code itself and run it right through the browser, or eyeball it if you want to before you decide to install the application to make sure it's not doing anything malicious, which I can assure you it is not. The program defines a number of standard libraries. The software serial used for communication with the Bluetooth module, the U8G library for the graphic control of the display, wire.h for the I2C, and these two libraries used for getting pressure data from the pressure sensor. Now, in the introduction, I believe that I said it used ports 5 and 6 to communicate with the Bluetooth module. It's actually 6 and 7. I apologize for that oversight. Now, here's where I actually instantiate the pressure sensor object, the graphic object, and the software serial object. Define some variables used by the program, the string that's received over Bluetooth, and the length of that string when it's divided up looking for communications that it needs to act upon. Variables to store the pitch and roll, which are transmitted from the Android device over Bluetooth. The X and Y position on the screen of the box that's drawn, the size of the box, and some conversion variables to convert the pressure sensor data from pascals to inches of mercury. A few flags used to control various functions of the program, and then a subroutine here that centers text on the Nokia display. In the setup subroutine here, we flip the screen upside down because of the orientation of my particular screen. Crank up the sensor module itself. Now, I've opened a serial communication port for the purpose of monitoring it. Those functions are actually turned off in this demonstration, but there is a section below where you may want to turn it on when you're setting the baud rate to a higher speed to communicate with the Bluetooth module. I'll get to that later. Define the transmit and receive pins that are used by the software serial module, and then set up the Bluetooth connection itself. That's down here at the bottom. It's actually just one line of code. Bluetooth serial begin 57600. There are two additional subroutines here, one to display the box if it's in communication with the Android device, and one to display a message asking you to connect if it's not. So the main loop of the program checks to see if the X and Y coordinates have changed, and if they have, it repositions the box. If it's not connected via Bluetooth to the Android device, it displays the message above. It then checks to see if any serial data has come in over Bluetooth, and if it has, it waits for a carriage return in the incoming text string, and then checks for the command that it's received and acts upon it. If it's gotten roll data, it sets the X coordinate on the screen based on that. If it receives pitch data, it sets the Y coordinate. If it receives box data from the slider on the Android app, which I will show you here in a minute, it changes the size of the box. This sets the flag to indicate whether or not it is connected to the Android device object. And this is a request from the Android device for pressure data to be sent to the Android device, and it sets a flag here. Now, if that flag is set, then it gets pressure data from the sensor and sends it out over that software serial to the Android device. just loops through that over and over and over again, updating the position of the square on the screen, looking for changes in size or requests for pressure to be sent. Now, I kind of glossed over this earlier, establishing the Bluetooth connection. Now, by default, the Bluetooth module that I had came from the factory with a 9600 baud communication rate, which was way too slow to adequately receive the data being sent from the Android device. So you can see right here it's set to 57600. That's because I've already changed it. But from the factory, you may need to remark this section out and unremark this section, establishing a connection at 9600 and then changing it to 57600, and then remarking this back out and re-implementing this section of the code and running the program again. There's also a section here that changes the default device name of the Bluetooth module to Arduino. I think that makes it a lot easier to find in your list of Bluetooth devices on the Android device. That's all there is to the Arduino side of things. Now I want to talk a minute about the Android side of things. Before I delve into the Android AppInventor code itself, I do want to talk briefly about what AppInventor is. AppInventor is a new and unique way to simply develop Android applications using a graphical drag and drop application. If you're familiar with another MIT programming language called Scratch, it's very, very similar to that, although focused more on Android applications. There are basically two parts to developing the code. The blocks of code themselves, defined as language blocks. Those blocks are subcategorized and color-coded. Control blocks, logic blocks, math blocks, text blocks, list blocks, etc. You'll see how all those tie together when we get to the demonstration code itself. And on the screen layout side of things, there is the components. The components consist of things like screen and user interface components, like text and text boxes, buttons, sliders, things of that nature. The other components used by this demonstration program are the sensor components, the tilt and roll sensor, the position sensor built into the Android, used to pull that data so that it's sent over Bluetooth to the Arduino. This will all make more sense once I jump over to the code and you see how it all works. Now that you have a basic understanding of what AppInventor is, let's take a look at the AppInventor code for the demonstration program that I've written. What you're looking at here is the designer screen where you actually lay out the components on the user interface and define various constants for each of those components. Now, some are hidden by default, so I'm going to click this box here so that you can see everything that's normally there. There is a connect icon, which is actually a button. Over here you can see the actual properties of that component. You can see that it has a name and an image associated with it. There's also text here that goes with that button, which will change color, and the text changes depending on the status the program's in. This is nothing more than just a simple label. Below that, there's actually text that's displayed when the program's running that shows the pitch and roll data from the Android sensor. This button is available to be pressed to make a request to the Arduino to send pressure data back over Bluetooth. Below that is some, at the moment, invisible text that would display the pressure that's sent back from the Arduino. This slider box in the actual application goes clear across the screen, not just this little icon that you see here. The text below it changes depending on the position of the sensor to indicate the size of the box that will be drawn on the Arduino. There's a disconnect icon, which is also a button, and some disconnect text as well. Now these 4 components here aren't represented in the user interface. They're components used by the program for communicating via Bluetooth. There's a clock module, which there's a timer used to check once a second to see if any text has come in over Bluetooth, which would be the pressure data that was requested. This notifier component is provided to be able to display a message to the user if the Bluetooth is turned off on the Android device. The orientation sensor component allows tilt and roll data to be pulled from the sensors in the Android device so that it can be transmitted over Bluetooth. I'm going to turn this back off so you'll see what you see when the program is first started. I'm going to jump over here to the blocks side of the IDE, which actually shows the blocks of code. We'll start up here at the top. This first block, just as a moment here before we start, as you can see, the blocks are modular. It's all drag and drop. You just build it component by component, and it's a lot like Scratch if you're familiar with that. This block handles things that need to be executed when the program is first run. I guess it's kind of like the equivalent of the setup routine on the Arduino. It checks to see if Bluetooth is enabled, and if it's not, it uses that notifier component to display a message requesting that the user turn on the Bluetooth. Now, when the connect button is pressed on the application, it changes the button text to connect, turns it blue, it hides the disconnect buttons, and fills the list picker with a list of Bluetooth devices to which the user can attach. This block of code handles the Bluetooth device that was chosen, setting the Bluetooth to that device, sending text to the Arduino that it's been attached. This actual code right here is not actually used by the program and could actually be removed. Sets the text on the screen to connected, turns it green, and makes the disconnect buttons, or the disconnect icon, now visible, and turns the connect icon invisible. Checks to make sure Bluetooth actually is connected, then sends out the position of the box size slider over Bluetooth to the Android, or to the Arduino. This block of code handles when the slider is moved, changing the size of the box, and sending out the new box size out over Bluetooth to the Arduino. In the event there were to be an error connecting via Bluetooth, this block of code displays the error that occurred, makes the disconnect button invisible, makes the connect button visible, and allows the user to attempt reconnecting to the Bluetooth device. This is that timer routine that I was talking about that checks once a second to see if text has come in, and if it has, sets the pressure text to the text that came in. This block handles the tilt and roll sensor. When the tilt and roll changes, it transmits the roll and pitch data out over Bluetooth. This block handles when the request pressure button is chosen, sending text out to the Arduino requesting pressure be sent back. And this block handles disconnecting from the Bluetooth device. It sends text out to the Android to let it know that it's going to disconnect, actually does disconnect, turns off, or actually blanks out the pressure and orientation text, changes the text under the connect button back to blue, displays connect, and hides the disconnect buttons. That's all there is to the code. It's actually very, very simple, especially with the drag and drop part of it. So I guess all that's really left at this point is to show you a demonstration of how it all works. Alrighty then, let's see it all in action. First thing I'm going to do is reset the Arduino and reset the Bluetooth module as well. Going to run the demo app, and as you can see, it opened up here with the same components displayed that you saw on the browser here a second ago. Going to press the connect button, choose the device to connect, in this case the Arduino, and we're now connected. And as you can see on the screen here, we have a small box. I can move this slider and increase the size of that box or decrease it in real time. And if I pick the tablet up and tilt the tablet, you can see the box moving around there in a corresponding manner. So it just responds to the tilt sensor info that's being transmitted over Bluetooth to the Arduino. If I press the request pressure button, the Arduino takes a pressure reading and sends it back in the other direction over Bluetooth to the tablet. Now if I slide this box down to say size 13 and then disconnect, move the box to say 19 and then reconnect, it will automatically readjust the size of the box to the new size, because that box data is sent as soon as it connects. So again, I can disconnect, I could shrink it way down, say to size 3, connect again, and the box is tiny. As I mentioned at the beginning of the video, this was not intended as a full-blown product, but more or less a proof of concept, give you some idea of how easy it really is to communicate back and forth over Bluetooth with an Android device, and how easy it is to write an Android application to work with the Arduino using the AppInventor. Hopefully I've provided a simple enough explanation of the basics to allow you to implement your own Bluetooth enabled Arduino project. I would love to see what sort of ideas you come up with, and I encourage you to experiment. What sort of ideas do you have? Leave your ideas in the comments below. And of course, I encourage you to click that like button if you found this video of value, and subscribe as well if you're interested in seeing more Arduino based videos from me in the future. Until next time, have fun.